Hello everyone. I am your teacher Chris again, and here we have our first lesson in Chemistry 100A. And in this lesson, we will talk about matter and separation techniques. As you know, chemistry or CHE 100 is chemistry for engineers, so we need to discuss separation techniques in order for you to gain skills and knowledge about the separation techniques you will deal later on in the field. So let's go now to our lesson. We have here what is chemistry? Normally, when we say chemistry, the easiest meaning for that one is chemistry is the body of science that studies and deals with the properties and also the reaction and changes and interaction of matter. Okay, so it actually deals with matter itself. But according to Google Dictionary, it is the branch of science that deals with the identification of substances of which matter is composed, that the investigation of their properties and the ways in which they interact, combine, and change, and the use of these processes to form new substances. So from reactant, you have reaction to form the product. And those substances are all matter. Okay? So let's go to the next one. Now, what is matter again? Simply means matter are any substances that occupy space and has mass. Okay? Sometimes there's another meaning for that one. Matter is also anything that occupies space and has volume. So what does space mean? Space mean, according to dictionary.com, it is a continuous area or expanse in which it is free or available or unoccupied. So it is a certain area that nothing is in it. Okay? In layman's term, vacant. Okay? And now, what about volume? Volume simply means the quantity of three-dimensional space enclosed by a closed surface. For example, if you have a bucket of water and you put a rock or any stone on it, so the stone occupies a certain volume, and also the shape or the total area of the enclosed by a surface of the stone is what its volume. Okay? Now let's go to the next one. Now, what are the important units on this lesson? We have volume, we also have mass, and we also have density. So volume has a unit of either liters, milliliters, you can say ounce, you can also say cubic centimeter, and you can also have cubic meter. Later on in our lessons, I will give you um, all the units used in volume for measuring. Okay, but liters, milliliters, and all of these are the common ones that we deal with chemistry. What about mass? Mass is actually doesn't just mean weight, but actually it means the total amount of a substance. So for example, for that mass, we have the unit grams, we can have kilograms, we also have ton, okay? And these are the most common ones that we use for grams. There are a lot, okay? There are a lot, especially in metric system, English system of measurement. There are a lot, but these are the most common ones we deal with when we're studying chemistry. What about density? Density simply means the mass of a substance over the volume of it. So the units for these one are just the ones that you can see above. So we have here for mass, you can use kilograms, grams, or ton. Then you have the volume of liter, milliliter, ounce, cubic centimeter, and cubic meter. Normally, we also have the other one we call dm cube, or the equivalent value for dm cube is simply the liter. So 1 liter is equal to 1 dm cube. Okay? So, and we have here, the most common one we use are grams per milliliter, and that is the common unit we used in chemistry. Okay, what about the states of matter? States of matter are the physical appearance or state of a substance or matter. So we have the most common ones. We have three. We're talking about solid, liquid, gas. And as you can see on the particle diagram above, you can differentiate automatically the difference between the three. Solid, as you can see, as a particle, they are really close to each other. Sometimes they are called, the word for that one is compact, and also they have fixed shape and sometimes a fixed volume. Then we have also the other one, we have liquid. Yeah, solid have fixed volume and fixed shape, while liquid, there are space between them. They are not really that far from one another, but they are not really close to one another. That's why you can see water, you can touch water, because not like solid that it's really compact, but it's not like gas that is really far away, that causes the gas to be invisible. While liquid, you can see liquid, you can put it in a container because liquid can occupy the volume or the space inside a container, while gas can still occupy the space inside a container, but the difference is it's too far from one another. This causes the characteristic of a gas to be invisible. But not all. If you have a chlorine gas, which is pure chlorine gas, you can see the color yellow, because chlorine gas at its purity is color yellow. But the air we breathe, the air in our surroundings, is invisible because as the chlorine gas, for example, will be dissolved in the air, it causes the characteristic of being yellow to be dissolved also, causing it to be invisible. What's the good thing about being air as a solvent? The good thing is it will evenly distribute the amount of gases in the surroundings. Imagine if you are inside a room that has full of oxygen gas, but outside the room doesn't have any oxygen gas. When you go out, you will die because oxygen is the one we use to survive, right? So let's go to the next one. We have here properties and changes of matter. So first property is what we call physical property. When we say physical property, it can be seen, touch, taste, and you can use your five senses. The difference is you did not there is no such thing as changing of its chemical composition. So it doesn't undergo chemical change, but it undergoes physical change. When you say physical change, the product will still have the same chemical characteristic or composition of the reactant. So for example, we have a tree or a wood. When you chop wood to make firewood, the firewood or the product firewood will still have the characteristic of a wood, right? That is what you mean when we say physical change. There are many things in our surroundings that are undergoing physical change. Another one is cutting of paper. So you just cut the paper and it's still paper, right? Maybe it becomes a small pieces, but it's still the same. It's still paper. Now let's go to the next part. The next type of property and change that our matter undergoes is chemical property. When we say chemical property, it means the product has now a new chemical composition that is different from the reactant. It also undergone chemical change. So in chemical change, the reactant reacts and forms a new product. When we say new product, the new product doesn't have any characteristic, or it has new characteristic than compared to the reactant. So for example, we have a firewood. When the firewood will be burned, so we add heat or we add fire, it creates ash, right? And also some gases, and we produce energy. These are the products when we burn firewood. Now, it doesn't carry the characteristic of a wood anymore, or it has now a new characteristic. You cannot say that ash has the same chemical composition of firewood. Normally, it's only carbon. Then you have also the gases like carbon dioxide and carbon monoxide. Those are different chemical characteristics than a firewood. And also, you produce energy. So that is mainly the difference between a chemical property and the physical property. What about this one? Now, even though matter undergone chemical change that causes it to have a new identity or characteristic, but according to the law of conservation of matter, matter is neither created nor destroyed in any process. What does this mean? It simply means that matter cannot be created. It means it must be from one type of matter. If it undergoes physical change, it forms the same matter, right? Because the only thing that changes is the physical appearance. But when we say chemical change, the matter, the type of matter on its reactant changes or form a new type of product. But even though it has different chemical characteristic, the type of matter here only produce a new type of matter. So it means the matter was conserved because it only changes from one form of matter into other form of matter. So if, in theory, if you can collect, for example, the ashes, the energy produced, and all the gases that was produced from the reaction of firewood and fire, you can actually form again the wood or the firewood itself. But that is in theory. But realistically, it will be hard. But it will. It is possible. Okay? So let's go to the next one. Now, what are the types of substances or the types of matter we have in our surroundings? So first, we need to understand the number of types of molecules that it has. So there are two types of matter in that category. We have one type of molecule only, and we have two or more. When we say one type of molecule, that matter is called pure substance. From the word itself, pure. It doesn't mix with other substances or other molecules. So under pure substance, we have two again. Uh, it categorizes on the number of types of atoms in the molecules. So if it only carries one type of element or one type of atom, therefore it's an element. Okay, but as you can see at the bottom part, we have another box, right? When we say one type of atom only, normally we put in our mind that it's only one atom alone. But in nature, gases, for example, a chlorine gas, exists together with another chlorine element. So, example, we have chlorine gas is composed of two chlorine atoms. You cannot see in nature on a single atom chlorine. It would be hard, and nature doesn't do that one. Okay, so in nature, we collect the chlorine gas, but still it belongs to element because it carries only one type of atom, right? But there are two atoms that are the same, that are bonded together to form gases. Okay? So, but there are gases that are also living alone. Do we call them? Or they can live on its own. Okay? We call them the noble gases. Example for that one are helium, neon, argon, and we have the xenon. Okay? So those are the noble gases, and they can actually live alone because they have the complete set of valence electrons. They are already very stable. So when you say noble, it only means they are stable enough. It's like they are independent enough. Okay? So let's go to the next one. We have mixture. So in mixture, from the word itself, mix. So they are they are composed of two or more um, types of molecules together. So from the word mix, right? It's not one type of substance that is in there or type of matter that is in there, but there are also other substances that are mixed together. So, what are the two types? We can categorize mixture into two types by looking at the distribution of molecules. So, in the first set, we have homogeneous mixture. It simply means homo means one, and it means one phase. When we say one phase, you cannot distinguish by looking at it the different substances that are mixed on it. It's like uh, it's like the air. Air is an example of a homogeneous mixture. You cannot differentiate the nitrogen and the oxygen in the air because they are all invisible, and there is only one phase. As I have said earlier, when you look at a chlorine gas, it's yellow. But when it is dissolved in the air, it turns into invisible. Why? Because air has the characteristics of being invisible, and that is its phase. And that is a very good example for homogeneous mixture. Another type for solid are alloys. The brass, the bronze, the aluminum alloys, and the steel are of solid homogeneous mixtures. And okay, so the next category of mixture is heterogeneous mixtures, in which particles that are present in heterogeneous mixture can be easily identified or can be distinguished from one another because they have different phases. Example for this one are oil and your water. If they are mixed together, they will have two different phases because oil will not mix evenly with water. Actually, they will just separate from one another. Another example are your stones and your, let's say, ping pong balls, right? They will not mix together because um, they will be easily be identified from one another. Okay, so let's go now to the next one. We have separation techniques. that is used mainly in industry because our class focuses on the chemistry in the industry. We have density for physical separation, particle size, molecular polarity, boiling point, freezing point, solubility of the components, and the techniques and methods used. So most of them are uh, can be found in when you are dealing in the industry. For example, there we have particle size. We use filtration method. So, for example, you are trying to filter uh, oil or you filter water from the particulates. We can simply use filtration method in order to filter out the water from the particulates that is suspended in the water. Okay? Next, we have molecular polarity. We use chromatography on that one. Okay? So, boiling point, simple or fractional distillation so that we can separate different types of substances by their boiling point. A great example for that one are petroleum industries. They use fractional distillation to separate different types of petroleum oil or products like kerosene and diesel and gasoline and also the asphalt. Then freezing point, we have low temperature separation or extraction. Then solubility of the components using the solvents like water and alcohol as the polar solvents, and non-polar solvents like hexane and chloroform. And there are a lot of solvents that you can use. Okay. Next, we have the things you need to do now. So please, on our next lesson, please study the symbols of some elements and identify the elements and atomic number and atomic mass of the elements. Then choose 5 elements from the periodic table, like 1 non-metal element, 2 metallic elements, 1 metalloid, and 1 radioactive element, and make a video on the things you understand about them. This will be passed on Monday next week, July 20, 2020. So, that's it for this lesson, guys. Hope you learn a lot from this and see you in our next online class. That's it.